Hello everyone, welcome back to the channel. We are doing Leetcode 970 powerful integers. The problem statement says given three integers x, y and bound, for example 2, 3 and the bound is 10, return a list of all powerful integers. So you have to return a list which has all the powerful integers. Now what are powerful integers? We are going to see that have a value less than or equal to bound. Now an integer is classified as powerful if it can be represented as x to the power I. So x to the power I plus y to the power j for some integer I is greater than equal to 0 and j is greater than equals to 0. Right. You may return the answer in any order. In your answer, each value should occur at most once. So if you think about it, 2 to the power 0 plus 3 to the power 0 is 2, then 2 to the power 1 plus 3 to the 0, 2 to the power 0, 3 to the power 1, 2 to the power 1 plus 3. So it's increasing like in binary 0, 0, 1, 1, 0, 0, 1, 1, 1, you know, not actually binary, yeah, but in that way. So incremental increase, right? And you just have to sort of enumerate all the possibilities up and until 10, starting from the very least number up and until 10. So over here, similarly, you have 3 to the power 0 plus y to the power 0, then 3 to the power 0 plus y to the power 1, y to the power 0 plus 3 to the power 1, which would be 4, so on and so forth. So if you have a look at the constraints are actually very low. 10 to the power 6 for the bound. At max, you would have to go till 10 to the power 6, and x and y are 100. So this means that we can very easily apply an O of n linear solution. So we can very easily enumerate all the possibilities. So without any further thinking, let's first try to achieve that that possible scenario. So what I'll do is, first of all, I'll have to create a vector integer answer array. Okay, and then I need to work with two powers. So x to the power I and then y to the power j, and I need to increment them one by one, one by one. Now thing is, you don't beforehand know how that at max how much you're going to increment the power of x and how much you're going to increment the power of j. So you kind of need to do that at the same time, right? So what we can do is maybe something like this: for int I equals 0, I, or maybe uh let's say, um what would be the actual condition, what would be the condition at which my loop exits? That condition would be my highest number. I think I'll just take it for now as -1, and what I'll be doing is I will be saying, or since the first number is 2, let's, the first number is always 2, right? If the, and the bound can be 0 actually. So if the bound is 0, then you need to return an empty array, because, and even if the bound is 1, you cannot make 1, right? So if bound is less than equals to 1, just return answer from here, because there's no, that's not possible. Even if you have any number in the world, to the power 0 is 1, to the power 0 is 1, so the least number which you'll be able to make is 2, right? So yeah, I'll be doing is I'll have to calculate uh, a high, or maybe int number, something like uh, power of x to the power I, and then plus power of x to the power, um sorry, y to the power I, y to the power I, right? Okay, yeah, chalo, I'll take a boolean variable here. Boolean stop equals to false, and I'll say I need to continue the loop as long as stop is equals to false is true. If it become, if a stop becomes true, then I need to break out of the loop. Okay, Sure, sure. Can I do something like this? No, probably I'll have to define the Boolean variable beforehand. Okay. Um, Similarly, or I can maybe say that this is going to be my A, and I can have four such lines for B, C, and for the four possibilities C and D. So what are the four possibilities? It could be I plus 1 over here, it could be I plus 1 over here, and it could be I plus 1 and I plus 1 over here, right? And what I'll do is before I push everything in the answer, I'll push everything in a set so that it's so that the unique constraints, where was it mentioned? Your value, each value should occur at most once so that that condition is met. Okay. Now what I'll do is I will see if before inserting I'll see if a is less than equals to bound, right? So I'll insert that in the set st dot insert a, right? Similarly I'm going to do for b, c, and d, for all of those b, c, and d. Okay. What I will do is, even if as soon as I enter the loop, I'm going to mark stop as true. Okay. And then when any of these conditions is met, I'll mark the stop as false. So, which means that, continue further exploration. If a stop is false, the loop won't break out. But then in a scenario where all of these, where neither A, neither B, neither C, neither D is less than equals to bound, then it probably means that you need to stop, right? Because now you're getting much higher numbers than bound, and you're going to get much higher number than what the limit of bound is, right? Then I need to iterate over for every number which is there in the set. I need to push back that number inside my answer dot pushback I, answer dot pushback I, and then I finally need to return answer, right? It's probably going to pass the sample test cases. It does not. Why? Empty array. And then over here an empty array. Why is that so? Because um, x to the power I plus y to the power I, then if the stop is less than false, if it's true, then continue. So if I, for example, try to debug this d and then c and then d, if I debug this, I'm not getting any, which means I'm not entering if bound is less than equals to 1, bound is not. Which means there is something wrong over here, right? This is not working. I don't know. Oh wait, so maybe this I was actually assigning it a value, whereas I should have given it a comparative. Alright, this was the problem, right? um so 2 3 4 5, I'm not getting 9 and 10. Why is that? And over here I'm not getting 10. 10 is something which I'm not getting. Why? What am I missing? So I do I plus 1 I and I plus 1 and I plus 1 and I plus 1, right? So 0 0 1 0 0 1 and 1 1. What's missing? And then I do I plus plus. 2 to the power 0 plus 3 to the power 2. Yeah, that's not going to, that's not a difference of, yeah, makes sense. Perfect. Makes total sense. So we are thinking in the right direction, but the way we are implementing this is probably not correct, right? So I need a different way. I need a better way of implementing this, so that I could deal with 2 to the power 0 plus 3 to the power 2 as well. And over here, it's basically this 10. Why did I miss 10 in this approach? Is because it's x square plus y to the power 0, x to the power 2 plus y to the power 0, right? So I need a better way, I need a better implementation of just the middle part. Better implementation is needed over here. Let's think about how we can do that. So for example, there could be this scenario that, you know, I hold, so I have 2 3 and what was it, 2 3 and 10, right? 2 3 and 10. So I do something like this: for 2 to the power 0, 3 to the power 0, then for 2 to the power 0, 3 to the power 1, for 2 to the power 0, 3 to the power 2, so this gives me 2 3 9. Then for 2 to the power 0, I do 3 to the power 3, which is greater than 10, right? So I stop the 0 series over here. Then I start 2 to the power 1, 3 to the power 0. So it's going to be how much? 3. Then 2 to the power 1, 3 to the power 1. So it's going to be 5. 2 to the power 1, 3 to the power 2, it's going to be greater than 10. It's going to be 11. So I stop the 1 series and then I start with the 2 to the power 2 series, 3 to the power 0. So this is going to be equals to 4, 5. But 5 was already included over here. So we are not going to take it again, and the set basically is going to handle that case. 2 to the power 2, 3 to the power 1 is 7, 4 plus 3 is 7. We are going to include that, and so on and so forth basically. So one loop for I, another loop for j, and we keep on incrementing the j up and until the value which we are getting is less than our bound, right? Yeah. Okay. And I will stop when, what would be the breaking point for my for loop? It's going to be when 2 to the power I is actually, it becomes greater than what my bound is. Okay, because if you think about it, the last value which I'll be getting is 2 to the power 4 into 3 to the power 0. This is just, sorry, 2 to the power 3. 2 to the power 3 into 3 to the power 0 is still 9, although we did encounter 9 before, but then this is still 9, right? But then when I encounter 2 to the power 4, it's already greater than 10, right? It's already 16. So it doesn't obviously make sense. If I multiply it with some number, it's not going to get any shorter, right? It's not going to get any smaller, right? So that would be the breaking point for my for loop. Okay. So rather than having one loop, I need two loops. I is less than actually nothing. But let's just say 100. Let's just say we'll break out of this for int j equals 0, j is less than 100, j plus plus, right? And what do I need to do? I need to calculate the number like this. So power of x to the power I plus y to the power j, right? Y to the power j, and then I need to see if number is less than equals to bound. So what do I need to do? If number is less than equals to bound, I need to push it in the set. Push the number in the set. If number is not less than equals to bound, then what do I need to do? I need to break out of the loop, right? Break out of the j loop, increment the I, start all over again, right? And I'll just have a simple condition over here. If power of uh, x to the power I, if it's greater than bound, then just break out of here, right? Yeah. So if I just did this part, I just had to redo this part. the other logic remains the same. It passes the example test cases, and I hope it passes the overall test cases as well. It does, right? So we did this question in this particular video, and the next one we are going to do a harder version which involves powerful integers, and we are going to do this particular these are not actually related to each other that much, but then this would be the next question that we solve. So I hope you found the video helpful, and I'll see you in the next one.